Now the same galvanometer can be converted into an voltmeter also. Okay, like how do we convert it to voltmeter? Now see, voltmeter, if you have noticed, everywhere voltmeter will be connected in parallel, because see, it should measure the voltage, correct? And in parallel voltage remains the same. So if the since galvanometer has very low resistance, and if you are connecting that in parallel, then almost every current flows through that, correct? Right, so that will damage the galvanometer. So what we do is, to calculate the voltage, we connect the galvanometer with a very high value of some resistance. Okay, like in ammeter we were connecting a parallel resistance. Here we will connect in series. Okay, so as you can see in the circuit, a galvanometer and some sort of resistance. Okay, some resistance which we can actually calculate. Alright, so in this case, so what we have is, we have a galvanometer and a resistor in series. The whole combination is what we call as an voltmeter. Okay, so this is a voltmeter. Now, first thing, we need to calculate, how do we calculate the resistance of the resistor? Okay, now see here, what we know is that the same current flows through the galvanometer as well as the resistor. Correct? So since the current is the same, we need to take this into picture and we need to calculate it. So the galvanometer current, we call it as Ig, right? So Ig is equal to V divided by G plus R. G is the galvanometer resistance, R is the resistance of the resistor. So we have V by Ig is equal to G plus R. So R is equal to V by Ig minus G. So once we have the voltage, the current and the galvanometer resistance, we'll get to know what is the resistance of the resistor which we have to use. Understood? So once we have that, so next video you will see one of the problems, like how do we calculate the resistance.